right now, but we'll find the x-intercepts and y-intercepts and we'll get a better view at this. Matter of fact, I think I'll draw it real lightly right now and then I'll go over it later. So my estimate is that it's going to be something like this. But let's find the x and y-intercepts and we'll get that perfect. So our asymptotes, first of all, would be right here. This one is x equals -4 for my vertical asymptote. And this one down here is y equals -2 for my horizontal asymptote. For my x-intercept, I would plug in 0 for y. So that means I would, right here where this y is, I would put 0 equals 3 over x plus 4 minus 2. And to solve that, I could add the 2 over. Now your students haven't done the solving section yet. That's one of the later ones in the chapter. That's something your PLT could talk about. You might like to do that before this. You might like to move that up. But I also think my students probably could come up with a cross multiplying to solve this, if nothing else. And then they would have 2x plus 2 times 4 is 8 equals 3. 2x equals subtracting over -5, and x equals -2.5. And so that's pretty close to where I guessed my x-intercept would be. For my y-intercept, I'm going to plug in 0 for x. There was my x-intercept. You might like to have them write that as -2.50 because they're really likely to get that mixed up with the vertical asymptote when they're looking. So to write it as point, because that's what an x-intercept is. For the y-intercept, we're going to plug in 0 for x. So I'll have 3 over 0 plus 4 minus 2. And that means it'll be y equals 3/4 minus 2. So 3/4 minus 8/4 is -5/4, or -1 1/4. And that would make the point, let's see, we plugged in 0 for x. And so I'd have -5/4, or -1.25. And that's pretty close to where I guessed on that one as well. So I did all right. I'm going to go ahead and draw this in now that I had those intercepts. It made a little more accurate graph, but I was going to be able to guess it pretty well. If it was multiple choice, I probably would have been able to guess the correct graph from that. My domain now is all real numbers. Let's take the short possible way to write this. This symbol for all real numbers, x not equal to -4. And my range is all real numbers, y not equal to -2. Hopefully your students will start to catch on to that these are the excluded values in the domain and range. All right, and so that's what they should be finding. There's 2 more problems like that in the technology exploration. So here's one where there's nothing added on. And so if I was doing this as a class, I would ask them to predict, is this going to slide sideways or up and down? And hopefully they'll know, because it's a number with x, that it will slide sideways, +2. And so they could get that. And then this one should be sliding -2 and then up 3 is what I would predict on that. So that's the technology piece. And that's what they're supposed to do with that one. The second part is a book assignment, and if you look at the assignment sheet, the book assignment says 1, 2, 5, 6 through 8, 10 through 13. This is a reasonable length assignment. After having done that exploration, the students aren't quite ready to do the assignment, because what we haven't talked about is what happens when a is negative, like number 1. So let me show you that in the book. By the way, on the technology piece, there's some other ones you could do. 5 we didn't do, 6 we didn't do, 9 we didn't do, and 10 or 11. Of all of them, 10 or 11 is probably the least helpful. And I think the ones that we picked because they are most like the form that we've learned the shifts in, and they'll keep things as simple as possible. Advanced math students would often do the other ones. So in this next section, you'll notice right away, for 1, they have a negative in front of the A. -3 on the top. 2 has 10 on the top, so that one's just like the 7 one that we did. That would be fine for homework, but we need to talk about negatives before you could just send that home. And then here on this page they have a nice box summarizing everything about the vertical asymptote, the horizontal asymptote, and when A is negative, it's going to reflect across the x-axis and be just like a parabola does, reflects across the x-axis. So will our reciprocal function. And so this kind of puts everything together right here, putting all that stuff we learned. So if you can go relatively quickly through the technology piece, if you haven't spent too long talking about homework, you could probably then talk about the negative, wrap that up, and be able to send the book stuff home with the students. That would be possible. After, let's see, let me look at what the assignment problems were. You also want to talk about number 7 and 8 when you send them home. Let me show you that one those really quick. It says write an equation for the translation of y equals 2 over x that has the given asymptotes. So they need to think about, where should I put a plus or minus 4 to make this happen? And where should I put a plus or minus 4 and a plus or minus 8 to be able to make these asymptotes happen? And so you may want to do an example like that so they could do those home. If you've done that, if you've been able to do the technology exploration and wrap up with those things, then you could assign the bookwork for homework. I think that they should be able to do it fine. Numbers 10, 11, 12, and 13 pretty much are just summary questions like that. And so not too hard at all. Okay. If you had a block day, you could do all of that, let them work on that in class, and then you could send them with homework the worksheet part. In the work part, there's 2 different ways you can access it. In this packet, let me see if I can put this together. Some schools are using this as an assignment packet, maybe with some of these assignments edited. And worksheet 1 through 6 is right here. There's the 1, lots of ABCs. Remember, there's 26 problems altogether on that part. Worksheet 2, 1 through 5 is really all of these mini problems, including some pretty tricky graphing, harder than actually what gets on the test. But pretty tricky factoring. But factoring was one of the things that students had a lot of trouble with in Unit 3, and so we want those skills to go away. And so that's why that's there. Worksheet 3 is this little extra section here. That's a lot of problems. It's A through N, so that is a ton of problems there on the adding and subtracting. Definitely looks like it should be 2 days. And worksheet 4 is right here. This is our graphing piece. These 8 problems. Here are the directions, and here are the 8 problems. The last 4, all you have to do is state the asymptotes. So they're very short. You don't have to do all the graphing and stating the asymptotes. That same worksheet all made up as a handout that students would write on. So if you are rich with paper and you would like to do that, here we have the same exact problems. They're not different problems, and the parts right next to it. Here's 3 and 4 and the parts right next to it, and then 5 through 8 state the equations of the asymptotes. And so this is the exact same problems, just in a different format, and your PLC lead should be able to get you access to either copy of those worksheets, give you both of those, whichever you prefer. So when you get that one, you can. This is an assignment they should be able to do 100% on their own after the other experiences, so sending this home would be great. My picture on a block day would be to do both of the first 2 parts in class, the technology exploration, wrap up, and then the book stuff in class, send home this worksheet. And otherwise, I would say I do the technology exploration and try to wrap up with the pieces they would need to do the book part at home, and then answer questions on the book part the next day, and then have them work this worksheet. So that would be my advice for you. Actually, the worksheet might be easier than the book part. No, you need the other one first. So yeah, so that's all there is for this. For those of you who've taught advanced math, there's a lot more complicated things about graphing rational functions that we don't go into. We are saving that for advanced math. So try not to kill the kids off. Just do the part they really need. Continue to emphasize the shifts of functions. Okay, thank you very much.